Hi there, this is Professor Eckhouse, and I'm going to talk about today identifying and using slope. So what is slope? It's the steepness of something, basically. It's also called gradient or pitch, like the pitch of a roof. And you can see here, compared to the house that is flat or on level ground that they've cut out into the hill, how steep the hill is. So that is the gradient or the pitch or the slope of the hill. Right, there's an example of, we've got a pretty steep spike, it's at a pretty steep slope, and we can find out exactly what that slope is. So slope is defined as vertical change over horizontal change. In other words, what we call the vertical, remember if you're looking at a graph, the graph is the vertical, the vertical is here, right? And that is y. And this is the horizontal. And that is x. Okay, so vertical, horizontal. So the vertical change, in other words, how much it goes up over how much it goes over. So we'll say also the vertical change is going to be the change in y. Vertical is y over the change in x. All right, so change in y, the letter delta means, it stands for change in math and in science. Okay, so we can just abbreviate this basically to delta y over delta x, change in y over change in x. Another thing that we call this is the rise, and this is the run. Run means this direction, and rise means this direction. Right? So a positive rise goes up, a negative rise goes down. A positive run goes right, a negative run goes left. This is slope. Slope is what the letter we use for slope is m. Okay, so lots of things there, all equal to each other. Vertical change over horizontal change means delta y over delta x, which we call rise over run. Okay, so if I was looking for the slope between this point and this point, I would measure the rise, which is this direction, right? So the rise is going to be up 1. And then I would go right 2, right? So the run would be right, which is positive 2. So positive 1 over positive 2 is just 1/2. That is the slope of the line that would be formed joining those 2 points. Okay, so let's continue on. All right, so let's find the slope of this line here. So where will we start? Well, you're just going to find 2 points. Any 2 points will do. It does not matter which 2 points. I just try to find 2 points that are easy to find. And let's see, let's just find, I've got one here and I've got one here. I'm purposefully not doing the origin just because I want you to see that you don't have to use the origin. It can be any 2 points. Okay, it doesn't always pass through the origin anyway. All right, so now you're going to go up and then over to get to the point. Right, so up, the rise is the up, right? Rise is on top, and that was up 2. And then we went right, so the run is right, which is positive 1. Okay, so I'm going to put this in a more mathematical way. This is the change in y over the change in x, and that is the slope. So m is 2 over 1, which we don't have to put whole numbers over 1. We don't usually write it like that, so we're just going to say 2. All right, so give this one a shot, see what you can do with it. Find 2 points that are exactly on and where two of the hash marks cross. All right, so I see one here. I'm going to use a brighter color here, and I see one here. So we're going to go up and right to get to the next one. So change in y is the rise, and that is a positive 1. It went up 1 over, nope, didn't mean to do that, over the change in x. How much did the x change? Well, I went right, that's positive 3. So this is 1/3. So the slope is 1/3. Okay, give that one a try. All right, so I've got points. Where are some points here? I've got a point here, and I'm going to just go down the line until I find one that's an exact. All right, so it doesn't matter which one you start with. You'll end up with the same thing in the end. So slope is going to be change in y over change in x. If it helps you to write rise over run, you can do that. So the change in y is how much it goes up or down. This one's going to go down and then to the right. So the change in y is down 1, 2, 3, so negative 3, and to the right 1, 2, 3, 4. So right is positive 4. So this thing is negative 3/4. And that looks like a negative slope, and we'll talk about that in just a moment. So remember this about fractions. Remember when you have a negative 1/2, that is the same thing. It equals negative 1 over 2, and it also equals 1 over negative 2. So it doesn't matter whether the change in y, so remember at the top is the change in y, the bottom is the change in x. It doesn't matter which one's negative. So it doesn't matter which way you count. Right? So we could come back up here and count the other way. We could go up 3 and left 4. So the change in y was a positive 3. The change in x was negative 4. We still get negative 3/4 because it doesn't matter if the negative is on the top or the bottom of the fraction. It means the same thing. Okay, so moving on. Draw what a positive slope looks like and what a negative slope is. All right, so a positive slope in general looks like this, or like that, or like that. So as you're moving from left to right on the x-axis, you are going uphill. So a negative slope is going to go the other way, like that, or really steep like that. And the idea is, again, you're reading the graph from left to right, just like you read a book, left to right, and you would end up sliding downhill as you go left to right. Okay, so that's a negative slope. All right, so just had some funny pictures here. Positive uphill on the left, negative downhill on the right. Okay, so positive, you're always moving from left. So in these, to think about whether you're going uphill, you think I'm going left to right, am I going up or down? Here I'm going left to right, I am going down, so it's negative. All right, formula for slope. Rise over run, delta y over delta x. So that's the main idea there, that is the formula for slope. And we're going to have the rise over run, again, is going to be from here to say here. The change in y is going to go down, and the change in x is going to go to the right. Okay? All right. So what if we were just given 2 points on the graph and used to find the formula? We have to use the formula to find the slope. So we're going to check by just counting between points. So what formula do we have here? If we had 2 points. So if we had 2 points and one of them is x1, y1, and the other one is called x2, y2, what would our formula be? Well, okay, let's look and see what would happen here. So let's say this first one is this one here. It doesn't matter which is which, x1, y1. And this one is x2, y2. So to find the difference between the y values, we would subtract the two y values. So delta y is measured by y2 minus y1 is traditionally how we write it. It doesn't matter the order, as long as you do the y's and the x's the same. And then the change in the x is going to be this x value here subtracted from that one. So it would be x2 minus x1. Okay, so there's our actual formula for slope. All right, so let's try find 2 points on this graph and use the formula to find the slope. All right, so we've got, let's see, let's just use easy one, 0, 0, and then 5, 2. Okay, so we've got 0, 0, and we've got 5, 2. 5, 2. All right, so delta y over delta x means y2 minus y1 over x2 minus x1. In other words, subtract the y's and then subtract the x's. But you just have to do it in the same order. It does not matter which of these is our y1, x1, y1, and which ones are x2, y2. It does not matter. But I'm just going to do randomly say, all right, this one's going to be my x1, y1. This one's going to be my x2, y2. So let's subtract y2 minus y1. 2, that's this one, minus 0. That's that one right there. All right, over x2, which is going to be 5. That's that one right there. Minus 0, that's that one right there. All right, so continue on. 2 minus 0 on top is 2. 5 minus 0 on the bottom is 5. So the slope is 2/5. That's m. So now let's check by counting. We're going to go up 2 over 5. 2/5. So it works. We did it right. All right, so it's 2 different ways. One's if you're just given points, and the other is if you're given a graph. We're doing it both ways because I'm hoping you connect them. So find 2 points in the graph and use the formula to find the slope. Check by counting between points again. So I'm just going to pick 2. Here's this one, and a good one would be maybe this one right here. So try it from there. All right, one of my points is 0, 2. That's this one right here, 0, 2. And the other point is 5, negative 1. All right, so m is going to be y2 minus y1 over x2 minus x1. All right, so the difference in the y's, okay, so the y's are going to be these two right here. Okay, so negative 1, I put too many equal signs, didn't I? All right, negative 1 minus 2. All right, now I have to go in the same order. I said negative 1 minus 2. Now I have to say 5 minus 0. 5 minus 0. That's going to be that minus that. Those two right there. You must subtract in the same order. Okay, so that's all there is to the 2's and the 1's as the subscripts there. Okay, now be careful. Negative 1 minus 2 is negative 3. 5 minus 0 is 5. So we get a slope of negative 3/5. So now let's check. We're going to go down, down 3. So that's negative 3, right 5. There we go. There's our negative 3/5. All right. So graph y equals 4 and find the slope. Y equals 4. Y equals 4 is right here. And find the slope. All right, let's pick 2 points. So I've got 0, 5, and I've got, let's do 5, 5. 5, 5. All right, so 0, 5, and 5, 5. All right, so change in y over change in x. So we get y2 minus y1 over x2 minus x1. All right, so my x's are going, or my y's are going to be the second one, of course. So I get 5 minus 5 over, and then I've got 5 minus 0. That's going to be my x's over 5 minus 0. All right, so 5 minus 5 is 0. 5 minus 0 is 5. 0 over 5. 0 over anything is 0. Slope of 0. Does that make sense? Yes. It doesn't have a slope. It's flat. It's like a flatlands, right? It's like a basketball court. There is no slope. All right, so no slope. But the way we say it in math is we say m equals 0 for any horizontal line. So if you know it's a horizontal line where y equals some number, then the slope is going to be 0. You don't have to find it. If you can just remember the horizontal lines have a slope of 0, that would be the best. All right, let's do the same thing for x equals negative 2. All right, so x equals negative 2 is right here. X equals negative 2 looks like that. So let's pick a couple points. So we've got negative 2, 0. And then I'll do, I don't know, negative 2, 4. All right, change in y over change in x. The change in y would be the y's here, 4 minus 0. And the change in x is going to be negative 2 minus negative 2. So negative 2 minus negative 2. All right, so I get 4 over negative 2 plus 2 is 0. All right, what just happened? We've got 4 over 0. What are we going to do with that? Well, we get undefined. Undefined. The slope is undefined. And that is true for all vertical lines. The slope is undefined. All right. So graph and label the following lines on the coordinate plane and find the slope of each. I'll do the first one with you. So the first one is x equals 7. X equals 7 is a vertical line through x equals 7. So I'm labeling it. So it says to label. So you just want to label so we know which is which. And that one has a slope is undefined. Undefined. All right, so continue on with the rest of them. All right, y equals negative 3. Y equals negative 3 would be right here. And that has a slope of 0. X equals negative 2 would be here. And that is slope is undefined. It doesn't have a slope. It's vertical. All right, y equals 5 is going to be right here. And that has a slope of 0. All right, so what about x equals 0? All right, well, x equals 0 is the y-axis. That's what x equals 0 is. It's the y-axis. And that has slope undefined. And y equals 0 is going to be, I'm going to do a different color. What color should I use here? I guess I'll do red. All right, it's really fat because that's what I was doing before with this. All right, let me fix that. So we've got, this is going to be y equals 0. Right there. So that has a slope of 0. It's flat. It has a slope of 0. All right. So in summary, The slope of a vertical line, x equals a, is undefined. The slope of a horizontal line, y equals b, is 0. In other words, m equals 0. All right, so a quick guide to the slopes of lines right there. You might want to have that in your notes with a big box around it. All right, so given the 2 points called x1, y1 and x2, y2, here is our slope equation. Find the slope of each one. So remember, x1, y1 is 1 point, x2, y2 is the other point. It does not matter which is which. So we're going to practice these and do them and graph them if we want to check. Okay, so find the slope of the line through these points right here. So now we're not picking the points, we are given the points this time. So they're given to us, and we have to find it. So m equals y2 minus y1 over x2 minus x1. So you can again make either one, whichever one you want, but I'm just going to go, first one is 1, second one is 2. All right, so that's going to give me 4 minus 3 over 2 minus 1. Now, if you didn't do this already, you might want to pause now and see where I got those numbers. Make sure you know where they're coming from and that you could do that yourself. So I get 4 minus 3 is 1, 2 minus 1 is 1. So let's check by graphing. The first point is 1, 3 right here. The second point is 2, 4 right here. Our line would look like this. Does that have a slope of 1? Well, yes, I go up 1 over 1. So the slope is actually, you would write that 1 over 1 is just 1. The slope is 1. So that's our final answer. And the slope of the line, that's what we're looking for. All right, try the same thing with number 11. All right, so we get y equals, the change in y is going to be 4 minus negative 3 over negative 3 minus 2. All right, let's keep track of which ones we used here. This is our y's, and these are our, trying to change colors and it didn't work. These are our x's. Okay, so just keep track and do everything in the same order. If I take the second one minus the first one for the y's, I have to take the second one minus the first one for the x's. Okay, so I get 4 minus negative 3 is the same thing as 4 plus 3. And on the bottom, I've got negative 3 minus 2 is negative 5. So I get 7 over negative 5. Or m equals, sorry, I didn't mean to say y equals right up here. Goodness, that should be m equals. I hope I didn't do that before. No, I didn't. Okay, m equals. I'm making this video late at night. I am getting very tired, so hopefully I don't misspeak too many times. All right, so negative 7/5. All right, so my points were 2, negative 3, and negative 3, 4. All right, that's a pretty big distance. So let's try this. We're going to go 1, 2, 3, 4, 5, 6, 7 up. That's plus 7. And then left 1, 2, 3, 4, 5 over negative 5. Negative 7/5. There we go. All right, so there's our final answer. All right, find the slope of the line passing through those 2 points and use the graph to check. So try it again. All right, so m equals, we're going to take the y's and put them on top, because remember it's change in y on top, change in x on the bottom. So change in y is our yellow. So that's going to be negative 1 minus negative 6 over, now we're going to do the x values, and we're going to get 3 minus negative 4. Why don't I say negative 4 minus 3? Well, I would be going in the opposite direction of what I did with the y's. You've got to go in the same direction. I said negative 1 minus 6. I said this one first minus this one. So I've got to say this one first minus this one. All right, so let's continue on. We get m equals -1 plus 6 and 3 plus 4. Remember, minus a negative is a plus. So that's 5/7. 5/7. All right, so let's try graphing these and see what we get. -4 and -6, and then 3 and -1. Ooh, pretty far apart again, so let's try this. So we're going to go 1, 2, 3, 4, 5. So I went up 5, and then I went 1, 2, 3, 4, 5, 6, 7 over 7. 5/7. All right, so our line would look like that. All right, number 13. What is the rise and run of a line with a slope of 2? So remember that m equals 2 means 2/1. So this is our change in y, that's our rise, and this is our change in x. So the rise is 2 and the run is 1. So compare that to a line with a slope of m equals 1/2. So if m equaled 1/2, that means that the delta y is 1 and the delta x is 2. So if we were starting at 0, a slope of 1 would go up 2 over 1, and it would be there, up here, like that. Whereas a slope of 1/2, I would go up 1 and over 2. It would be not nearly as steep. It would look like that. So this is m equals 1/2, a slope of 1/2, and this one is a slope of 2. M equals 2, or 2/1. All right, graph the line going through 0, 0 with a slope of 1. So remember that a slope of 1 means a slope of 1/1. It's going through 0, 0. So we just go up 1 over 1. There we go. If you want more points, up 1 over 1, up 1 over 1, up 1 over 1. There you go. So it doesn't matter what 2 points you would pick, you would find it had an up 1 over 1 slope. All right, graph the line going through 0, 0 with a slope of -1. All right, so here's 0, 0. Slope of -1 means -1 over 1, or it could mean 1 over -1, either one. So this is a change in y. Let's do the first one. Let's do this one. So starting, I'll do that in blue. So starting here, I'm going to go the rise, oh my goodness, I'm writing backwards. No, I'm getting tired. The rise is -1, and the run is 1. So that means the delta y, and that means I go down 1. So down 1, right 1, and I end up there. Down 1, right 1, end up there. Or I could do the other one, or I could do a rise of 1 and a run of -1. Well, let's try that. In fact, I'm going to make that one a different color so you can really see the difference. So this one's going to be green. All right, so the rise is going to go up 1, but the run is going to go left 1. And look at that, I end up still on the line. It doesn't matter which one I call negative, I end up with a line that all the points are like this. I have a hard time drawing in that direction. I don't know why. There we go. All right. Next one. All right, graph a line given a point and a slope. Plot the given point. Use the slope formula to identify the rise and the run. Start at the given point, count up and over, connect the points. That's what I've been doing already. So nothing new, but there's the list of how to do it. So graph the line passing through 1, -1, whose slope is m equals 2/3. Okay, so first we have to start here. That is step 1. Okay, 1, -1 is right there. All right, step 2 is count up and over. All right, so I'm going to count up 2. So up 2, right 3. And there's my next point. I could go do it again, up 2 over 3, there's my next point. And then I'm going to connect the dots. And that's it. That's my line. Okay, why don't you try that one? All right, it says has a y-intercept of 0, -2. So y-intercept is just a point. It's just a special point. And it has a slope of 3/5. So that means we're going to go, remember this is delta y, and this one is delta x, rise over run. So we're going to go, and they're both positive. So we're going to go up 3, 1, 2, 3, and to the right 5. 1, 2, 3, 4, 5, to right there. And so my next point is right there. I could do the same thing by having -3 over -5, because that's still 3/5, right? Negative over negative. So I could go down 3 and left 5, and I end up there. Am I still on the line? Yes, I am. So if you are good with, whoa, that was really just too bad. I got to start over. If you're good with your fraction negatives and understanding what to do with the negatives, it makes this easier. All right, try that one. All right, x-intercept 1, 0 is here. A slope of -3 means m equals -3 over 1, or it could equal 3 over -1. As long as the 3 is over 1. It's not 1/3, it's 3 over 1. All right, so m is -3, so down 3 and right 1, and we get right there. So now make sure that your slope is kind of, in one of those kind of things. It's negative. It should be going down to the right, and that one is. It's really easy to mess those up. Or we could use this one and say up 3, 1, 2, 3, up to here, and left 1, and that would land me right there, and it's still on that line. So doing 3 points never hurts. It's also easier to draw a better line. Okay. Some slope applications. The pitch of a building's roof is the slope of the roof. Knowing the pitch is important in certain climates, like where we are in Vermont, when there's heavy snowfall. If the roof is too flat, it may cause the roof to collapse. So what is the slope of the roof shown? So this is really how they measure roofs, but they call it a pitch. So how much do you go up for how much you go over? So m is going to be the rise over the run. So we get 9 feet over 18 feet. 9 feet over 18 feet. That was a mess. So the feet are going to actually cancel out. And 9 over 18 is 1/2. So the slope is 1/2. All right, last one. Find the slope of a road with a rise of -15 and a run of 40. So the slope is going to be, again, the rise over the run. So the rise is -15 and the run is 40. So it's going to be negative. This reduces by 5. So how many 5s are in 15? 3. And in 40, 8. So I get -3 over 8. And that is a downhill slope. All right. Thanks for sticking through to the very end. That was a long one.